fires earlier or later, and you get higher voltage or lower voltage. Higher voltage, right faster. Lower voltage, fast forward. This is called armature voltage control behavior. Alright, and then for different characteristics, we will look at the behavior of the motor. Alright, or rather this one. What are the things you need to fill in? So yeah, thank you. You need to fill in all this. First of all, you got to connect the circuit as shown that one. Alright. After that, we'll just start with the minimum firing delay angle, maximum firing delay angle. That means almost close to 0, 180 degrees. So that starting, remember you start the DC motor, you need to have a reduced voltage. Otherwise the starting current too high. You blow the fuse. So we start at very low voltage, starting at 150. Yeah? We start with 180 first, turn the knob. The knob is where? The knob is over here. Right? And bring down here. Okay. Knob is here, right? Okay, the knob is here. Baby doesn't drop the feet, that's why you're very true. This knob, the electronics inside. When you turn this knob, you can delay the firing of this one. Earlier, you know what's the reference? The reference is the zero crossing, right? Yeah, okay. Therefore, this is zero crossing, this zero crossing, this zero crossing. So you delay how much before you fire. So when you fire here, let's say here, this part will be allowed to go through. Remember you did the experiment number 2? This part is like that. Okay, this is alpha. So you turn this, you adjust the firing for this part. Later or earlier. Earlier more voltage, higher speed. So you have to fill in different values of this and fill in the corresponding DC voltage you measured and the speed and so on. Okay? On the next table, you can bring down. Yeah, okay. Yeah, this is good. So you start with 150. Alright? So how do you get 150? This one, you measure, look at scope is the time. So you have to do proportional. I think this one, if you can still recall for those good memory ones, lab 2, right? Remember, you use, instead of using a motor load, the output of the rectifier. This one is the one we bring down, but lab 2 we are doing this, lab 2. Can you remember? Can you remember we did it? Can't remember. Now we are going to use it because this one is electromagnetic. So its behavior is slightly different from here. But the angle is the same. No? So this one is 150. Right? How much is 150? I don't know because this one is in time, right? So we know that this one 1 over f, right? Which is equal to how many milliseconds, anyone? 350 Hertz. You 1 over 50 second, 20 milliseconds, right? Yeah, okay. So this is 20 milliseconds. So this one is equivalent 20. So you want how many? 150, right? Anyone work out for me how much is that? Should be less than
300 by 360.
Less than 10, because it's less than 50%. Less than 50%. Less than 50%. 8 point something, right? 8.33. So you adjust the knob. That's the knob until this one shift to how many? 8.33 milliseconds. This one is equivalent to 150. Okay, got it? Then you what to do? Very simple. Let's take the, can shoot up again. Take this reading, this meter connected. So take this reading, record down. Then you have it IA. What is this reading? Record down. Then speed, right? Speed. Speed also. Speed. You got the tacho. Yes, yes. There's a tachometer. You can put on the shaft here. It's a contactless tachometer. Yeah. You shine on it. Huh? You press. You see the slide, right? So you shine on this. This one is a rotating shaft, but there's a tape, reflective tape on this. So you can shine on it, then you reflect back, and then you count how many thousand. And then you record down what is the memory. Once you release the button, you store in the memory. Okay? Contactless, huh? Contactless. So you record down this as RP, I think RPM. So
per minute. RPM.
oh, okay. So you record this, and last one is you record this. What's the last thing to record?
N is a number.
N is the speed, number of
EB.
EB. EB a bit tricky. Come, bring down, okay, sorry. Bring down, please. Okay, the model for this one is, remember? EB, right? Right, EMF. Oh. Right. So how to measure this? Inside, how to measure? There's current flowing through it. There's RA, right? Do you remember your formula? This VA, RB. Yes, good. VA equals to IA, RA, EB, right? So now the problem is, you have to measure this. How to take away this? This inside the model. Algebra. Doing algebra. You look at the waveform here, you see that the one recorded over here, you look at this one. This one will be this one. Then this is DS, DS. So this one is red. Red. But you must put a differential voltage for us. Remember? Times how many? 200.
1,000.
No, 1,200 times 200. Okay? So this one will show you this. Please remember that. Remember the voltage. Remember this, right? So this one is here. But how about this one? This one don't measure two channel, right? So this one will go again. Differential voltage probe. Times 200, red, black, and this one go to your channel 2, this go to channel 1. This one will be the V dot, right? Or V dot is over here. So now you can see these two on the scope. They're just a knob, this one move. Okay? So how much? Move to 8.33 milliseconds, stop there. That is the required setting for alpha equals to 150. Okay? Then you measure, look at reading here, record down, look at reading, record here. Look at the, measure the tachometer, contactless, and also measure this. How to measure this? Now this one you look at waveform, you see that at this part when it's having fire, there's no voltage here, right? Actually it's not true, because when you have a fire, there's no current flowing here. There's no current flowing here. What happened? Zero. This part, zero. So what you measure here is actually EB.
Exactly.
Alright? So then if you look at here, look at the scope, you'll find that it's not like that. This one is for the resistive part. For the voltage, the motor drive part, you see this. You see this? You see a zero, you see. So this is the part when you have a fire, right? So this is actually So look at the waveform on the scope. You can measure DB. Okay, all done. Right, for 1 second. Clear? Okay, let's go one more time. What is the second one? And 120. You go back to the top of it. So on 120, same thing. What you do is adjust it down. Check 120 first. 120 over 360 means 120 equivalent to 120 times 20. How much is it? Anyone? What's that? Huh?
6.66.
Okay. Alright, so you adjust this knob until this one move to what? Here. The firing is here. So this one move to here. So this alpha now becomes this one. Equivalent to 120. Okay? Then, and then the same thing, we measure this, record this, measure this. Read on the scope, what is it? Done. Actually quite easy, very fast. You know the process. So continue laughing. Very easy, Because I explained to you, you look at the road time, take another half an hour. Okay, can bring down, bring to the table then. Okay. Alright, so what you do is do this. Record. Do this. Record. You have to do until 60 degrees. But depends your luck. This feel okay. But up to around here, we have no problem because this one as you reduce the firing delay angle to shorter, you find that more current, more voltage, the thing run faster. But also you find that because of the saturation, wear and tear not the same. So some cannot reach 80, some can reach 90, some can reach 70. So these two readings are very fixed. You get these three. Then when you reach up to the last one, you can go to 90, you stop at 90. You go no more. Stop at 90, take the last reading. Okay, that much on machine. Then important thing is you need to draw the waveform. You need to draw the voltage waveform of the potential for 150 and 60. So 150 you have to draw this one, first one. Then 60 may not get it. You get 90, the last one, or 70, 79. This will be your last one. Okay? Draw the waveform for this one. Voltage waveform. And label the waveform back and back. And rectify the waveform. Draw this waveform. Draw this waveform for 150. And for the last one, maybe 60, yeah? If you are 90, then 90. Okay? Alright, okay now. After that, then you have a table here, right? Ready? You need to submit the report, graph the motor speed against the BBC, yeah? Right, you got BBC, and right out. Okay, so you get these two, get a few points. Okay, this is the first one. Explain briefly how the speed of the DC motor can be used by single phase half control rectifier. Alright, explain why this one. Okay?
Very easy.
Good. Okay, remember, connect everything up. Don't turn on the main power. Then call Mr. or me to check before we say okay, then you have power. Alright. This one do a bit more carefully because it will be one of the experiments for the test. Your test, which one you get, depends a lot. Lottery, you pick up. There are, I think, 3 or 2 experiments. Mix up. So which one you pick is what you're doing.